explain what heat capacity is, and I've also explained what specific heat capacity. Finally, heat capacity is the quantity of heat required to raise a substance by 1 Kelvin or by 1 degree Celsius. Why specific heat capacity is the quantity of heat required to raise a unit mass of a substance by 1 degree Celsius or by 1 Kelvin. That is by the way. How do we calculate heat capacity or the quantity of heat? We use our formula, which is H equals to what? MC theta. Where your M represents the mass of the substance you are dealing with, your C is the specific heat capacity which will be given to you. Remember, different materials, different substances have different specific heat capacity. And then this is the change in temperature. Let's take, for instance, calculate the quantity of heat required to raise 3 kilograms of copper by 10 degrees Celsius. Calculate the quantity of heat required to raise 3 kilograms of copper by 1 degree Celsius. We'll now say the heat equals to the mass. What is the mass? 3 kilograms. And what is the specific heat capacity? It will be given to you. Most times you see 390, which it will give to you, times what was the temperature by what? 10 degrees Celsius. And all you have to do is to press your this times this and this, and that is your answer. Don't forget, your units must be in joules because heat is measured in joules. Am I communicating? Now let's calculate the quantity of heat required to raise 4 kilograms of water from 10 degrees Celsius to 30 degrees Celsius. Calculate the quantity of heat required to raise 4 kilograms of water from 10 degrees Celsius to 40 degrees Celsius. Now we go. The heat required to raise it equals to the mass of the water, which is 4 kilograms, times the specific heat capacity of the water, which is what? 4,200. As long as you are given in kilogram, the specific heat capacity for water is 4,200. Then times the temperature. What was the temperature? From 10 degrees Celsius to what? To 40 degrees Celsius. So you do 40 minus 10, which is equal to what? 30. So this is the heat. So you press your 4 times 4,002, and your answer must be in what? Joules. You can press that, punch that in your calculator, and please give me your answer on the comment section. This is the first part of heat capacity. Next, we are going to be talking about how to determine specific heat capacity of a substance. I will start. There are 2 methods used to determine the specific heat capacity of a substance. The first method is mixture method, and while the second method is electrical method. Now let's go. Let me explain mixture method for us. For the case of mixture method, then we get a container, and this is what we want to determine the specific capacity. Let's say this is the copper. We want to determine the specific capacity of the copper. We will have what we call a calorimeter, where we have our thermometer inside and we have a stirrer inside, which is used to stir whatever is inside of this place. Now, we are heating this to a particular temperature. Let's say the temperature inside this water, inside this calorimeter, this is water, this is my water, inside this calorimeter. This is my calorimeter. This is my water inside calorimeter. Now, when I heat this, let's say the thermometer, the temperature here, let's say it was 10 degrees Celsius, for instance. Let's say the temperature here was 10 degrees Celsius. And then I heated this metal. I was heating it and heating it to the point that the temperature rose to about 70 degrees Celsius. And immediately I will transfer this metal into this calorimeter. What do you think will happen? Excuse me? The metal was inside this container that was heated up to a temperature of 70 degrees Celsius. Of course, the temperature here will be very hot. And immediately I transfer it into this container that has water, but the temperature before was 70 degrees Celsius. When I do this, take a time to think, what do you think will happen to the temperature here? Will it increase or it will decrease? Drop your answer in the comment section. Of course, what will happen? The temperature will increase from 10 to a certain number. Let's say when we added this metal into this container, the temperature rose to, let's say, about 50 degrees Celsius. Of course, ideally, that's exactly what will happen. Here, the temperature was 70 before. Here, the temperature was what? 10. Now, I transferred the metal that was in a container of 70 degrees Celsius into this place that was 10. the temperature will definitely increase. Let's say it has increased to 10 to 50 degrees Celsius. Now, what is the specific heat capacity of this metal? I'll now go by saying heat loss. Let's write it to a heat loss is equal to what? Heat gained. Now, which one is losing heat and which one is gaining heat? Obviously, this one is losing heat, while this one is gaining heat. This one is the one losing heat because the temperature has increased to this part, while this one is gaining heat. Now, let's determine the heat. Remember, heat is also given as H loss equal to what? H gained. And remember previously for heat capacity, the quantity of heat supply, we said heat is equal to what? mc theta. That is for this one. The mass of this metal is what we are going to write here. The specific capacity of this metal is what we are trying to determine. And then the temperature, you should know what the temperature is. Now here, the heat gain. What are the things that gain heat? The water inside this container must have gained heat. And also the container too, the temperature has increased. So what do I do now? The heat lost by this metal is equal to the heat gained by this container, which is equal to mc theta. Remember, heat gained by this is this. And also plus the heat gained by the water inside of the container, which is also plus mc theta. Now with this, you can determine the specific heat capacity. What do? We come and write our this plus this, and then we make this subject of formula by dividing it by what? Dividing it by what? N theta. Divided by what? N theta. So this cancels this. So our NC will be NC theta plus NC theta all over what? N theta. The value obtained is the specific heat capacity of this metal. Let's do a simple question. Now solve this question. Chibweze, try and solve this question. Chibweze Usoji, try and solve this question. And some of the students from Port Harcourt and Lagos State, ensure you solve this question and give me your answer in the comment section or on our WhatsApp group. Let's take for instance, the mass of this metal is 3 kilograms. And it was heated to a temperature of 70 degrees Celsius and quickly transferred into a copper calorimeter, which the specific heat capacity is 390. The specific capacity of this copper calorimeter is 390. And then this copper calorimeter weighs, let's say it weighs 5 kilograms. And then the water inside this container weighs 3 kilograms. And the specific heat capacity of water is 4,200. Determine the specific heat capacity of this substance. Next class, we will solve this question and we'll go to more questions you will see in your JAMB. Don't forget to subscribe. Thank you very much for being with us.